Hello my dear students, welcome to CP Live, YouTube channel of eCareer Point, especially for English medium. So how are you all? As I can see, hello Aman Gupta, hello, who is that? NA. So how are you all doing? Good? Today we are going to start this new chapter, Projectile Motion. In previous lectures, we have completed that previous chapter, Motion in One Dimension. Who's that? NA. You will get all the information on this channel for any new updates. Okay. Those who are new, I suggest you to subscribe this channel and hit the bell icon so that you can get all the notification of important quizzes on this YouTube and important lectures. Okay. So before starting this lecture, quickly share this session to all of your friends so that everyone can take benefit of these free YouTube classes by Career Point quota. Okay. So, hello Mohammed. Because we have studied previous chapter, Motion in One Dimension, I am telling you in this physics, especially in this mechanics part, every chapter is related to its previous chapter. Okay, so if you are new, I suggest you to watch my all previous lectures of chapter Motion in One Dimension, then you will have a good idea about this projectile motion. Okay, what is projectile motion? Let's start this lecture. See, actually, whenever we throw any object making some angle from horizontal on the surface of earth, the motion of that object is known as projectile motion. Okay, basically this velocity should not be perpendicular to ground. Okay, so see, before starting this lecture, let me introduce all of you to our toppers. These 4 students, they were studying on this eCareerPoint app, our app, and they have secured top 50 ranks. Okay, so this eCareerPoint app, this app is very beneficial for all of you, especially in this time of corona where you cannot go to your school and your favorite institute where you want to study. So by this app, you can take the benefit of quota coaching classes, Career Point at your home. So quickly download this app if you do not have. Downloading is very simple. Just go to Google Play, open Google Play and search for eCareerPoint without any space, and you will see this eCareerPoint learning app. Just open it and install this app. Installation is very simple. Then it will ask you to register. After registration, you will see this kind of window. Follow your experts. After downloading, don't forget to follow your experts, because after following, you will be able to attempt those questions, practice questions posted by your experts. Okay, and inside this free stuff, you will get all these notes which I am teaching you in YouTube. These slides where I will write, and all the PowerPoint presentation in PDF format you will get here, free inside free stuff. If you open free stuff, scroll it out, okay, and select medical, because I am teaching you for NEET. So scroll it after selecting medical, and you will see here this class 11th NEET 2022 English medium. Okay, motion in one dimension we have covered. Here you will see second chapter, that is projectile motion. If you open it, you will get all the videos of these lectures, although this is the first video, and the respective notes in PDF formats. Okay, so don't worry, you will get all these notes from this app. Okay, so we have both free stuff and paid courses on this app. If you want to purchase any paid course, use ST10 coupon code to get 10% discount on any purchase. Okay, so let's start this chapter, projectile motion. What is projectile motion? Listen carefully. See, suppose this is the ground. Okay, on this ground, if we throw any object in the sky, suppose we are throwing this object with a velocity u, making some angle theta from horizontal, okay, then definitely it will not have vertical motion under gravity. No, it will not have vertical motion under gravity. It will have this kind of motion. Okay, so this kind of motion is known as projectile motion. Okay, see, if the position where I am throwing this, if I consider this position as origin, and if I join initial point and final point through a line, and if I consider this line as x-axis and perpendicular to it as y-axis, it will be easy to do the calculation of this projectile motion. Actually, projectile motion is very simple, even simpler than motion in one dimension. Why? Because in motion in one dimension, we were having cases of different acceleration. Okay, we were having cases of different acceleration, and here acceleration is constant. That is why this chapter is easy as compared to the previous one. Okay, so see, if I assume this as x-axis, this as y-axis, okay, then this height, maximum height attained by this projectile from ground, I am talking about ground to ground projectile, so this height is known as maximum height. Okay, and the distance between initial position and final position where it strikes the ground, this distance is known as range. Okay, and the time taken to complete its journey is known as time of flight. Hello Nisha. So those who are new, I suggest you to subscribe this channel so that you can get all the notifications of upcoming quizzes and important chapters. Okay, this channel is new. This is especially for those students who do not understand Hindi. So this is for English medium, pure English medium. Okay. Yes, Nisa, it is sufficient. It is sufficient. I will cover that level also, so you can watch. And don't forget to subscribe the channel. Those who are new, subscribe the channel and hit the bell icon. Also, all of you like this session. Now, see this. So, what we are going to do in this projectile motion, we are going to find out what is the time of flight. What is the time of flight, and what is the maximum height attained by the projectile, and the range of projectile. Okay. So, let's start. Hello Saurav Guzer. Ram Ram. So, hit the subscribe button and press the bell icon if you are new. So, what is projectile motion? Technically, let's learn. If a constant force or acceleration acts on particle at some angle, and that angle should not be either it neither be 0 degree nor 180 degree. Okay, at an angle which is not 0 degree, also which is not 180 degree, with initial velocity, then the path followed by the particle is parabolic. Okay, it is parabola. It is not the straight line, but it is parabola. Also, we will derive the equation of path, and we will see that equation is quadratic, so it is parabola. Okay, in previous chapter, that was motion in one dimension, we were considering the motion of particle in a straight line. So that was a straight line motion, and this is motion in two dimension, which is projectile motion. Okay, so with some initial velocity followed by the path is parabolic, and the motion of the particle is called projectile motion. Okay, for example, see this. If this man throws his bat like this in the sky, okay, he is throwing this bat with a velocity u, okay, and definitely because this is throwing the he is throwing this near the surface of earth, so acceleration due to gravity is in downward direction. Okay, acceleration is in downward direction, and this is the initial velocity. Okay, So as you can see, the angle between initial velocity and acceleration due to gravity is neither 0 nor 180. So the path of this bat will be projectile motion. Actually, because bat is not of point size, so its center of mass will follow the parabolic path, which is known as projectile motion. Okay. Hello Ashish. Beta, those who are new, subscribe the channel. This is especially for English medium students. This is our new channel of Career Point Quota. So hit the subscribe button and press the bell icon. Okay. And we will cover all the possible questions in this chapter. Okay. That can come into your exam. See. So I think you got an idea what is projectile motion. If you throw any object directly upward, vertically upward. If you throw any object vertically upward, as you can see, acceleration due to gravity is downward. The direction of acceleration due to gravity is downward always, as you know. So angle between them is 180 degree. Or if you throw any object vertically downward with some height, acceleration due to gravity is downward, so angle between them is 0 degree. In these cases, the particle will not have parabolic motion. In these cases, particle will have only straight line motion. Ashish, this is projectile motion and it is very beneficial for you. Okay. So, see this. Ask your friends to join this session quickly. So, whenever angle is 0 degree or 180 degree, the particle travels in a straight line. In this condition, it will go up and it will come down along the same straight line. And in this condition, it will only come down with this straight line. So these two are not projectile motion. What is projectile motion? If you throw any particle in such a way that its acceleration is constant, having same direction, and angle between initial velocity and acceleration is not 180, also not 0 degree, then it will have this kind of motion, which is parabola, and this motion is known as projectile motion. So, dear students, as you can see, your biology teacher, Krishna ma'am, has joined this session. Wish her. Hello, Falguni. Thank you so much. So, one more thing. As you have already seen this game, how many of you have played this game? Angry Birds. See, the motion of this bird is also projectile motion. Why it is projectile motion? Because direction of acceleration due to gravity is in downward direction. And when you play this game, if you throw this bird with an angle, with some angle from horizontal, it takes parabolic path, which is projectile motion. Okay? Hello, Kumar Sudha. I'm fine, thank you. So how many of you have played this game? See, to play this game efficiently, you need the knowledge of projectile motion. If you know the path followed by this bird, you can easily think whether this bird will hit the target or not. Okay? Hello, Mr. Prakash, Vikas Prakash. Pranam. So hit the like button, all of you, and press the bell icon if you are new after subscribing. So this is also projectile motion. Okay. Now, see, to study this chapter, projectile motion, there is some requirement. Okay. The knowledge of those three equations of motion which we have studied in the chapter Motion in One Dimension, it is required to study the projectile motion. And those equations of motion are very easy. You are studying this equation of motion from 9th class. So all of you can understand this projectile motion. What are those equations of motion which are useful? First equation of motion, V is equals to U plus AT. Okay, where V is the final velocity, U is the initial velocity, A is the acceleration, and T is the time to change the velocity from U to V. Okay. Second equation of motion, S is equals to UT plus half AT square. Okay. This is second equation of motion in which S is the displacement, U is the initial velocity, T is the time, and A is the acceleration. And what is third equation of motion? it is v square is equals to u square plus 2as. Okay, so if you know these equation of motion, that means this chapter projectile motion is very simple for you. Okay, so this is first equation of motion, this is second, this is third. Okay, and what is the condition of these equation of motion? Are these equations of motion valid all the time? No, they are valid only if acceleration is constant. If acceleration is constant, then only you can apply these equation of motion. Otherwise, you cannot. But in projectile motion near the surface of Earth, acceleration is equals to 9.8 meter per second square, which is constant. So you can apply these equations of motion. Okay, if you know these equations of motion, projectile motion is very simple for you. Now, one more thing. See, the projectile motion is not motion in one dimension. Okay, it is motion in two dimension, because it is not having straight line motion, so it is not motion in one dimension. Then why we require these equations of motion? These equations of motion we have derived for straight line motion. Then how they are useful for projectile motion? See, because it is useful because the projectile motion can be considered as combination of these two motions. What are these two motions? Vertical motion under gravity plus horizontal motion without acceleration. Okay, so in this whole chapter we will consider that the projectile motion is combination of these two motions. How? What is vertical motion under gravity? It is this. If you throw this upward, it will come downward. If you throw any object upward, the object will come downward. So this is vertical motion under gravity. Okay, under gravity means acceleration is there, so velocity will change. Also, what is horizontal motion without acceleration? Horizontal motion without acceleration means having uniform motion. Uniform motion means the motion without change in velocity. Because acceleration is not there, so velocity will not change. So combination of these two motions is equals to projectile motion. This. See, if we launch a particle from this position and we assume that this is origin, okay, and if this is x-axis and this is y-axis, so as you can see, we can consider this motion to be the combination of this vertical motion and this horizontal motion taking place at the same time. Okay, if you assume this, calculation will be very simple, and that is why this chapter is easier than the chapter motion in one dimension. Okay, why? Because near the surface of Earth, acceleration due to gravity is constant. So this is motion under gravity, which is for constant acceleration. Okay, and in constant acceleration, you can directly use those equations of motion. Because we are considering that this projectile motion is combination of these two motions, so what we are going to do, we will use equations of motions separately in both these motions to find out the answers of questions related to projectile motion. Okay, so what is, see, if this particle is going like this, that means it is having horizontal motion also and this vertical motion also. Okay, now this vertical motion is under gravity, that means acceleration is there, but horizontal motion without acceleration. Why? Because motion is under gravity and acceleration due to gravity is totally in downward direction. There is no component of acceleration due to gravity in horizontal direction. Okay, that is why acceleration in x direction, or we can say the component of acceleration in x direction is 0. That is why I am considering that this is horizontal motion without acceleration. Okay, so these techniques we are going to use in this chapter. So now let us discuss about projectile motion on horizontal plane. Horizontal plane means we are talking about ground to ground projectile. What is ground to ground projectile? If we throw the projectile from ground and there is no obstacle in the path and this directly hit at the ground, then there is ground to ground projectile motion. Hello Devyani. See beta, those who are new, subscribe this channel. This is the new channel of Career Point, for especially for English medium only students. Okay, so this is for pure English students. So if you are new, subscribe this channel and press the bell icon. Now see this. If we throw a particle from this point with a speed u, as I told you, acceleration due to gravity is downwards. So angle between this u and acceleration due to gravity is not 180 and not 0 degree. So it will have a parabolic path which is known as projectile motion. Okay. Now, in the case of projectile motion, see, if you throw any object from any point, we will consider that point as origin. Okay, that position is origin. Good, Kumar. Devyani, don't worry, I will take those classes also. See, if I throw this particle with a velocity u and making angle theta from horizontal, then as I told you that I am going to consider this projectile motion as the combination of two motions. What are those two motions? Vertical motion under gravity and horizontal motion without acceleration. Okay, so I will make components of this initial velocity. As you can see, this vertical component, because you know the concepts of vectors, so this vertical component will be uy, which is u sine theta. If this is u, this is theta, then this component must be u sine theta, and this component is equals to ux, which is u cos theta. Okay, so see this, we have this velocity u and I have made components. The component near theta is u cos theta, which is ux, that means component in x direction, and the component, other component along y direction is u sine theta. Okay, I have made these components. Okay, remember always the component near theta is u cos theta and the component, this remaining component is u sine theta, and these two components are perpendicular to each other. Okay, so I am going to consider vertical motion separately and horizontal motion separately. So I will say, because this projectile motion is combination of two motions, that means for vertical motion initial velocity is u sine theta, and for horizontal motion initial velocity is u cos theta. Now, what is the direction of acceleration? The direction of acceleration is vertically downwards, which is equals to g. Okay, g is the acceleration due to gravity, which is the total acceleration experienced by this projectile. Okay, which is having projectile motion. So because g is the total acceleration, what will be the component of g in horizontal direction? Because it is making a 90-degree angle from horizontal, so its component in horizontal direction will be g cos 90, which is equals to 0. So if I divide, if I make components of acceleration, acceleration in x direction will be 0, but acceleration in y direction will be equals to this ay, acceleration in y direction will be equals to minus of g. Why minus g? Because I am taking upward direction as positive y, so acceleration is in downward direction, that is why I am taking it negative. Okay, so to solve these questions, to study this projectile motion, this is the simplest method, that consider this projectile motion as the combination of two motions, vertical motion plus horizontal motion. Vertical motion with some acceleration due to gravity and horizontal motion without acceleration. See, we are having x component of acceleration is 0, that is why I have written horizontal motion without acceleration. So listen, now comes the amazing part. We have acceleration in y direction. Okay, So because we have acceleration in y direction, so velocity in y direction will change, or I should say component of velocity in y direction should change. Okay, and acceleration in x direction is 0. If we have 0 acceleration, that means velocity do not change. So because acceleration in x direction is 0, so the component of velocity in x direction will not change anytime. Okay, that means suppose at t1 time, suppose at time t1 the particle is here and having some velocity v. Okay, then what will be the x component of velocity? X component of a velocity, which is vx, will be equals to ux, which is u cos theta. Why? Because acceleration in x direction is 0, so the x component of velocity will not change. But coming from this point to this point, there is some acceleration in y direction and it is negative. Initial velocity in positive direction, so y component will decrease. So I will say this y component of velocity at any time, which is vy, it is equals to, we can apply equations of motion. So if I apply equation of motion in y direction, I will get final velocity in y direction is equals to initial velocity in y direction plus acceleration into g, and acceleration is equals to minus g into t. Okay, so coming from this point to this point, okay, its velocity in x direction is same. Why it is same? Because there is no acceleration in x direction, but velocity in y direction has decreased. Initial velocity was uy, now velocity is uy minus gt. In 1 second, decrement in velocity in y direction will be 10 meter per second, because acceleration due to gravity is approximate 10 meter per second. Okay, now at the highest point, suppose at time t2, the particle is at highest point. So at this point, as you know, at highest point, if we talk about motion under gravity, at highest point velocity is 0. Okay, if we talk about motion under gravity only, at highest point velocity is equals to 0. Okay, but if we consider horizontal motion without acceleration, at any point velocity is not 0. So if I combine them, and if I want velocity at the highest point, this will be only vx. As you know, there is no acceleration in x direction, so velocity component in x direction will not change. At the highest point, again velocity in x direction is same as the initial velocity in x direction, because there is no change in velocity in x direction due to this 0 acceleration in x direction. So velocity in x direction is u cos theta. Okay, and at the highest point velocity in y direction is equals to 0. That means we can say that uy minus g t2 is equals to 0 at highest point. Now if this particle move forward, then suppose at this point when time is t3, what is the x when time is t3 and its velocity is in this direction. Okay, so the x component of velocity, suppose velocity is v, x component of velocity is equals to initial velocity in x direction, because there is no change in velocity in x direction, but y component of velocity is continuously decreasing. Okay, initially it was large, then it decreases about by some time, then it becomes 0. Now it is increasing in negative direction. So this velocity in y direction at this point, it will be equals to ux minus g t3. Okay, ux minus g t3, and at last velocity in x direction is same as initial velocity in x direction, and velocity in y direction is equals to negative of initial velocity in y direction. That means minus u sine theta. So this is the projectile motion, which is the combination of vertical motion under gravity and horizontal motion without acceleration. Is it clear to all of you? This is projectile motion. Between any 2 points, if you want anything, final velocity, displacement, what you can do? You can simply apply equations of motion in separate directions. Vertical direction separately, horizontal direction separately, and you will get the required parameters. Okay. Now see this. For horizontal motion along x-axis, parameters are shown here. For vertical motion along y-axis, those parameters are shown here. As I told you, projectile motion can be considered as vertical motion along x-axis and vertical motion along y-axis combinedly. Okay. Sadakat, let me know which step, which is last step. There is no step. I have just shown you a brief idea that at last velocity in y direction is same, but velocity in x direction is same, but velocity in y direction will be negative of velocity here. Initial velocity was uy sine theta, it will be in negative direction. Okay, so see this. Horizontal motion along x-axis. What is the initial velocity? Initial velocity is ux cos theta. So it is ux, which is equal to u cos theta. And what is acceleration in x direction? As we have seen, acceleration in x direction is 0. So ax is 0. That means velocity at any time t in x direction, we can use equation of motion. That means vx is equals to ux plus ax into t. Since ax is equals to 0, so vx is equals to ux. So at any time t, velocity in x direction is u cos theta. Okay. This is y. Okay. Now, if we talk about initial velocity in y direction, initial velocity in y direction is u sine theta. As you can see, the component of this velocity is upward, u sine theta. Okay. And acceleration in y direction is equals to minus g, that we have already discussed. Because there is acceleration in y direction, that means the velocity in y direction will increase in downward direction. Or if its initial velocity is in upward direction, it will first decrease, then become 0, then increase in negative direction, like this. Particle is going in this path, velocity in x direction is same always, but velocity in y direction is continuously decreasing, then becomes 0, then again increases. So at the topmost point, velocity in y direction is 0, but velocity in x direction is not 0. So the total velocity at the topmost point is parallel to the ground. Okay. And because there is acceleration in y direction, so we can say velocity at any time t in y direction you can easily get by applying first equation of motion. As I told you, because acceleration is constant, so we can apply equations of motion separately. Okay, we can apply equation of motion separately in x direction, separately in y direction. So if we apply equation of motion in y direction, first equation of motion, what is that? Vy is equals to uy plus ay into t. Ay is minus g, uy is u sine theta. So we have velocity at any time t in y direction as u sine theta minus gt. Okay, so there is no need to only remember this formula. You should know the concept behind that. Okay, you should also know the concept behind that. If you know this concept, if you know equation of motion, you can easily solve the questions of projectile motion. Okay. So those who are new, I suggest you to subscribe this channel, because this is our new channel, especially for English medium students. And you can invite your friends to take benefit of this free quota coaching classes on YouTube provided by Career Point Quota. Okay. So let us talk about the coordinates of particle at any time t. See, because this is not straight line motion, so the path is not having equation of straight line. Equation of straight line, you know, y equals to mx plus c. So this is the path of the projectile, so this is not a straight line. Okay, but if we assume that we are throwing this particle from origin, we can easily find out the coordinates of the particle at any time. How we can find out? Because we are considering this projectile motion as the combination of two motions in perpendicular direction. So we can find out by this coordinates at any time. Suppose at any time t, the particle is present here. We have thrown this particle with some velocity u at an angle of theta, and at this time it is having velocity v, and definitely because x component of velocity is same but the y component of velocity is decreasing, so the angle made by velocity by the horizontal continuously decreases up to this point. Okay, so if u is the initial velocity making angle theta from horizontal, then its initial velocity in x direction, that is ux, it must be u cos theta because this component is near theta, and this component in y direction uy is equals to u sin theta. Okay, also if we want the x coordinate and y coordinate of this particle after time t, we want x coordinate and y coordinate, what we can do? Listen carefully. The displacement in x direction, that is sx, is equals to x coordinate. Displacement in x direction is x coordinate, and this displacement in y direction sy is equals to y coordinate. Is it clear? If the particle is moving from here to here, it is not having straight line motion, it is having a curved path. Okay, this is parabolic motion. So from this point to this point, displacement in x direction, or we can say the component of net displacement in x direction is the x coordinate, and the component of total displacement in y direction is y coordinate. Okay, and we also know that acceleration in x direction is equals to 0 and acceleration in y direction is equals to minus g. We have acceleration in both direction, we have initial velocity in both direction, we want displacement at any time t. If we get displacement in both the direction, we will have coordinates at any time t. Okay, so this is how we are going to find out the coordinate. So let's start with x coordinate. See, displacement along x axis, that means I want displacement in x direction, that is sx. So displacement in x direction, how I can get? Apply second equation of motion in x direction. From this point to this point, if I apply second equation of motion in x direction, what is that? S in x direction is equals to u in x direction t plus half a in x direction into t square. S is equals to ut plus half at square, where s, u and a, they all are in x direction. So if I apply second equation of motion in x direction, first of all, this displacement in x direction is the x coordinate. So this sx is equals to x, and acceleration in x direction is equals to 0. So we got the x coordinate, which is displacement in x direction, is equals to initial velocity in x direction multiplied by time. So we got x coordinate as u cos theta into t. Is it clear to all of you? Now let us calculate the y coordinate by calculating displacement in y direction. Okay, So what is displacement along y-axis? Displacement in y direction, I'm assuming it is sy. Okay, so if I apply this second equation of motion in y direction, if I apply second equation of motion in y direction, that is s is equals to ut plus half at square, where s, u and a, they all are in y direction. Okay, displacement in y direction is equals to initial velocity along y direction into t plus half acceleration along y direction into t square. So displacement in y direction is equals to y coordinate. Initial velocity in y direction, uy, is equals to u sine theta. So put u sine theta here. T as it is. Minus, why minus? Because ay is minus g. Put value of ay, you will get half minus half gt square. So this is the y coordinate at any time. Okay. So if you put the value of t in these two formulas, you will get x and y coordinate respectively. Again, there is no need to remember these formula. You can easily derive this formula because you know the concept behind that. Okay, there is no need to remember each and every formula. Okay, try to remember the concept behind every formula and it will be easy for you. Is it clear to all of you? Okay. Next thing, angle made by velocity with ground, that is alpha. See, if I throw any particle with some initial velocity u, making an angle theta from horizontal, then because the angle between acceleration and initial velocity is not 180, also not 0 degree, so it will have parabolic motion, and its initial velocity in x direction, that is ux, is equals to u cos theta. Okay, if I take theta from here, then this will be u cos theta and this will be u sin theta. But I am taking theta from horizontal, that is why horizontal component is u cos theta, and this vertical component uy is equals to u sin theta. Okay, and we also know that acceleration in x direction is 0 and acceleration in y direction is equals to minus g. So the velocity will not change in x direction, but due to negative acceleration, the velocity along y direction will first decrease, then increase in negative y direction. Okay, so the topic is angle made by velocity with ground, that means with horizontal. Initially, the angle between velocity and the ground is theta, but because the x component of velocity at any time is not changing, it is always ux, but y component is decreasing. What is vy? It is equals to uy minus g into t. The y component is decreasing always. So see, this component is decreasing, and what is this velocity? This velocity is the vector sum of its components. So if this component decreases, this velocity will turn towards the x component, and finally at this position the total velocity will be along x-axis only. So this angle at any time made by velocity from ground is alpha, which is definitely less than theta. Okay, this alpha is definitely less than theta in this case. Why? Because the y component is decreasing, so this velocity is coming towards its x component. So alpha angle is less than theta. We have to calculate this angle alpha. That is our aim. Okay, angle made by velocity with ground, that is alpha. How we can calculate it? If I want to calculate tan alpha, okay, tan alpha. What is tan alpha? It is perpendicular by base. That means y component of final velocity divided by x component of final velocity, which is equals to x component of initially in x direction. Okay, see, so where is this? See, this is angle alpha, this is Vx, which is equals to u cos theta, this is Vy, which is equals to u sin theta minus gt. Now if I want to calculate tan alpha, what is tan alpha? In this triangle, because you know the vector sum of Vx and Vy is the actual velocity at this point P, which is V. So this tan alpha will be equal to perpendicular by base. Perpendicular is Vy, base is Vx. So Vy by Vx is tan alpha. Okay, and what is Vy? Apply first equation of motion in y direction from this point to this point. V is equals to u plus at. Ay is minus g, Vy we have to calculate, and uy is u sine theta. Okay, what is this equation? This is first equation of motion in y direction. So by which we got final velocity in y direction. So Vy is uy minus gt and Vx is ux as it is. So tan alpha is equals to Vy minus gt divided by ux. Okay. Now what is uy? Uy is u sine theta. Gt as it is, and ux is equals to u cos theta. That means we got, see, if we separate it, we will get u sine theta upon u cos theta minus gt upon u cos theta. Okay, so this u and u will get cancel out. Sine theta upon cos theta is tan theta. So tan alpha is equals to tan theta minus gt upon ux, or ux can be written as u cos theta. Okay, so this alpha is the angle made by velocity from horizontal at any time t. If you put in this formula the value of t, you will get tan alpha, where alpha is the angle made by velocity at any time t from the horizontal. Okay, so do you understand the calculation? Again, if you remember the concept behind it, it is easy to use this formula. Okay, try to solve projectile questions using equations of motion in separate directions. Okay, there is no need to remember all the formulas. If you know the equations of motion, see, we are using only equations of motion in separate direction to get anything. Is it clear to all of you? Okay, good. Now look at this question. By reading theory only, it is not sufficient for physics. You need to do some questions as example so that you can understand the concept. Now look at this question. This is x-axis, suppose this is y-axis, and we are throwing a projectile from origin, that means 0, 0. Now let's see what is the question. 1 second after projection, a stone moves at an angle of 45 degree with horizontal. 2 seconds after projection, it moves horizontally. Then find out its initial velocity. Now see this, if I throw a stone with some velocity which is unknown, which we have to calculate, from some angle theta, then it says that, as we know, it will take a parabolic path, projectile motion. Okay, the question says that 1 second after projection, a stone moves at an angle of 45 degree. That means at this point, that means the point at t equals to 1 second. This was t equals to 0. This is t equals to 1 second, and at this point the angle made by velocity vector from horizontal is 45 degree. 1 second after projection, a stone moves at an angle of 45 degree with horizontal. This line means this situation. Okay, next line, 2 seconds after projection, it moves horizontally. Let me know, all of you, at which point on this path the projectile moves horizontally for a moment. Use live chat and answer this question. In this whole journey, at which point its velocity becomes horizontal? See, the angle between velocity and the ground is decreasing continuously. So at which point this velocity becomes horizontal for a movement? Definitely at the topmost point. See, the angle is decreasing continuously, and at the topmost point, you know, velocity in y direction is 0 and there is velocity only in x direction. That means this is the velocity. Okay. So second line says that, good Sadakat, good, very good. See, the second line says 2 seconds after projection it moves horizontally. That means at t equals to 2 seconds. Okay, at t equals to 0 it was here, at t equals to 1 it is here, at t equals to 2 it is here. At 2 seconds after projection it moves horizontally. That means at t equals to 2 seconds it is at the top and its velocity is equals to only u cos theta. Why u cos theta? Because this initial velocity in x direction ux is equals to u cos theta, and initial velocity in y direction is uy, which is u sin theta. This is ui, and in this journey velocity in y direction decreases continuously and becomes 0 at the topmost point, but velocity along x direction remains the same. Here also velocity in x direction vx is equals to u cos theta, or you can say ux, and velocity in y direction here vy is equals to ux uy minus g into t. T is equals to 1 second, so I am writing 1 here. At this point velocity in y direction is equals to 0, which is equals to uy minus g, and t is equals to 2. Okay, and what we have to calculate? We have to calculate its initial velocity. So let's start solving this question. See, at t equals to 2 seconds, at t equals to 2 seconds, its velocity in y direction is equals to 0. And if I apply, good Kumar, see, let me mark the points. This is point O, origin. This is point A. This is point B. Okay. If I apply what? First equation of motion in y direction. If I apply first equation of motion in y direction from point O to point B, what will I get? What is first equation of motion? It is uy is equals to vy equals to uy plus ay into t. All of you know acceleration in x direction is 0 and acceleration in y direction is equals to minus g. Okay. So what is velocity in y direction at the topmost point? At the topmost point velocity in y direction is equals to 0, which is equals to initial velocity in y direction, that is uy, which is u sin theta. I am taking it uy minus g into 2. From this I got that uy is equals to 20 meter per second. Okay, what we got? We got velocity in y direction, which is u sin theta, is equals to 20 meter per second. Okay, but it is asking to calculate the initial velocity. So see this. Now what we are going to do? Let us discuss the situation at t equals to 1 second. At t equals to 1 second, see, that means here. Now if I apply first equation of motion from this point to this point, what will I get? I will get vy is equals to uy minus g into t. What is this? This is first equation of motion in y direction from O to A. Okay, first equation of motion in y direction. And what is the value of t? At t equals to 1, particle is at point A, so t is 1. Okay, the equation is this: Vy is equals to Uy plus Ay into T. Ay is minus G, Uy that we know. So what we got? See this. One more information, that 1 second after projection, a stone moves at an angle of 45 degree. Okay, the stone moves at an angle of 45 degree. If we know that, see, we know that the vector sum of x component and y component is the actual velocity. So actual velocity is making 45 degree from x component and 45 degree from y component. That means its x component and y components are same. This we concluded from the knowledge of vectors, because the vector sum is making equal angles from its components. So its components are equal. Okay, that means I can write Vy is equals to Vx only at t equals to 1 second. Okay, so at t equals to 1 second, Vx is equals to Uy minus G. And what is Vx? Vx is not changing. Vx is always equals to Ux. Vx is always equals to u cos theta, which is Ux. So what is this? This is equals to Ux, which is equals to Uy. What is Uy? It is initial velocity in y direction, which is a constant value, that is 20 meter per second. So this is 20 minus, what is G? In question it is given, take G equals to 10 meter per second square. So minus 10. So we got initial velocity in x direction as 10 meter per second. That means u cos theta is equals to 10. Okay, so we have this equation 2 and this equation 1. Now what is initial velocity vector? U vector. It is equals to under root of ux square plus uy square. So initial velocity vector is equals to ux square is 100, uy square is 400. So u is equals to under root of 500. That means u is equals to 10 root 5 meter per second. This is the initial velocity, 10 root 5. So answer is option 2. Is it clear to all of you? I can see some students are new. Hello Jyoti. See, if you are new, subscribe this channel to get the notifications. And Sadakat, what is last step? See, what is initial velocity? Initial velocity is the vector sum of these two components. U square cos square theta plus u square sin square theta is equals to u square. Okay, this thing I have used. Ux is equal to u cos theta, so u square cos square theta plus u square sin square theta is equal to u square, and under root of this is equal to u. Okay. So we can conclude in this question that initial velocity in y direction was 20 meter per second. After 1 second, it becomes 10 meter per second, which is equals to the horizontal component. And after 1 more second, it becomes 0, because acceleration in y direction is what? Minus of 10 meter per second square. So its velocity is decreasing 10 meter per second in 1 second. So initial velocity in y direction is 20 meter per second. Then after 1 second, it becomes 10 meter per second. After 1 second, it becomes 0. In next 1 second, it will become negative of 10 meter per second. And finally, it will become negative of 20 meter per second. And initial velocity in x direction was 10 meter per second, which is constant throughout the motion. Velocity vector in x direction is same at every place. See, after 1 second, in y direction, velocity from 20 to become 10. That is equals to the x component. That is why it was making 45 degree angle. Okay, so this is the basic idea of projectile motion. In next class, we will discuss the maximum height of projectile, the time of flight, and the range of projectile. Okay, to attend next class, you should know the schedule. To get the schedule, hit the subscribe button and press the bell icon. Also, all of you like this session and share this to all of your friends so that everyone can take benefit of this live classes. I have some homework questions for you so that you can practice. Practice will make you perfect in physics, because physics includes mathematics, and in mathematics practice is required. So this is the question for you and it is homework for you. Its answer is option C. It also based on the basic idea of projectile motion that we have covered today. Okay, this question is also homework for you. Its answer is option 1. Okay, so these two questions are your homework. Now to solve these homework questions, and if you want these slides as notes along with my written annotations, what you have to do, just download eCareerPoint Learning app. Now at last, see this animation. If we throw this projectile from here, the vertical and horizontal component are shown and their vector sum is the actual velocity, the resultant velocity. From down to top, its y direction velocity was decreasing and x direction velocity was same. And the y velocity is increasing in negative direction and x is always same. Okay, see this again. I'm throwing it from here. Y component is decreasing but x is always same. See, and at the top, the final velocity, actual velocity becomes only x component because y component is 0, and at this point the velocity or the speed is minimum, and then y component increases in negative direction and x is same. Okay, so x component is not changing, only y component is changing. Now to solve these homework question, and if you want slides, what you have to do, you have to download eCareerPoint Learning app. You will get all these slides with my written annotation. Okay, because to solve homework question you should know what is the question. So to get the questions and to get the class illustration along with notes and these slides, download eCareerPoint Learning app. From where? From Google Play. Just go to Google Play, search eCareerPoint without any space and install it. After installation, the registration is absolutely free. Register this and follow your experts. After following, you will be able to attempt the questions posted by your experts free of cost. Okay, and if you want these slides, just go here, free stuff. Go there and you will see this window. Select medical section because I am teaching in NEET preparation. So select free stuff and go here, go there. Scroll down and you will see this section, class 11 physics NEET 2022 English medium, and this is the first chapter which you can watch absolutely free, and this is second chapter which is projectile, which you will see on the app. Open this and you will get video lectures of the chapter that you have selected and the respective notes in PDF formats. Okay, here you will get notes and here you will get all the slides that you are watching here. Okay, so that is enough for today. Like this session, share this to all of your friends, and if you are new, subscribe the channel and hit the bell icon so that you can get the notification of upcoming lectures and you can see the schedule posted by community post. Okay, and if you want something more, let me know using the comment section. Okay, so before coming to next class, I suggest you to revise these notes and solve the homework questions. So let's meet in next class. This is Sumit Talwani signing out. Thank you very much.